All right, we are going to go ahead and get started here on our notes. We are going to be learning about the Pythagorean theorem today. So if you can make sure that you have your notes opened up, the very top portion says parts of a right triangle. And the Pythagorean theorem, I'm going to have another video that I want you guys to watch as well, where you'll be able to see me demonstrate why the Pythagorean theorem works. But the Pythagorean theorem is a theorem that we start learning about that only works for a right triangle. So when we are working with right triangles, one thing that you guys want to make sure of is that you've always got this right angle right here in the corner, all right? Because that right angle indicates we're dealing with a right triangle. So couple vocabulary words for you. The the side that is opposite of that right angle. So you can see here, I just drew my arrow from my right angle to this side right here called C. That side, C, is called the hypotenuse. Hypotenuse should always be opposite of your right angle, and the hypotenuse is always the longest side. So I want you to go ahead and write a little note down here. The hypotenuse is always going to be the longest side of your right triangle. And then the other two sides that we have on a right triangle, those are going to be the two sides that kind of like meet to make that right angle. So right here you can see that I have side A and side B, and they together are meeting, and they are what forms that right angle. Sides A and B are what we call the legs of our right triangle. So your legs are, we typically use the variables A and B for them. Now, it doesn't matter if you flip-flop these around, by the way. It doesn't matter if one of them is A and one of them is B. The legs are interchangeable. The C, that is the piece that has to be the hypotenuse. So the Pythagorean theorem is used to find the missing side length of a right triangle. And as I mentioned earlier, this only works for right triangles. The formula for the Pythagorean theorem is a squared plus b squared equals c squared. And again, with this formula, I've got a second video that I'll have you watch where I try and demonstrate for you why the Pythagorean theorem works the way that it does. But for now, this is the formula we will be using. So we will be taking one of the legs, squaring it, plus the other leg, squaring it, and setting that equal to our hypotenuse squared. So if we jump down to our next section, our directions here tell us that we need to find x. So we'll be solving for an unknown or for a variable here, and we have to round to the nearest tenth when necessary. So, but probably the most important thing when you go to use the Pythagorean theorem is I highly recommend that you identify your hypotenuse first. So your hypotenuse, like we talked about earlier, is always the side opposite of that right angle. So I can see right here that this variable x, that is my c value, that is my hypotenuse. So I'm going to go ahead, I'm going to write the letter c next to it. And because that is my hypotenuse, I can assume that the other two sides are my legs, A and B. And again, it doesn't matter which is A and which is B. So now that I've identified which variable each of these numbers represents here, I'm going to go ahead and instead of A squared, my A value is 12. So I'm going to go ahead, I'm going to write 12 squared plus, instead of b squared right here, I'm going to go ahead and substitute in my number 5 squared equals. And then instead of c squared, or equals c squared, I should say, I'm going to put equals x squared because this is our unknown that we're solving for. From there, once you substitute those in, you're simply going to be solving or simplifying each of these here. So I'm going to go ahead, I'm going to raise 12 to the second power because I've got to follow that order of operations and do my exponent first. So 12 times 12 is 144 plus 5 times 5 is 25 equals x squared. Once we take care of our exponents, the only thing we have left to do is addition. So I'm going to add 144 plus 25, and I get 169 equals x squared. And then your final step, we talked about this a little bit in 6th grade, is the opposite of squaring something. So our goal is to figure out what is x right here. So we're basically trying to figure out what number times itself, or x times x, is going to equal 169, right? Because x squared tells us to take our base x, multiply it by itself twice. So we want to know what number times itself is equal to 169. The easiest way to get that answer, some students like to do guess and check. I personally think the easiest thing to do is knowing that the opposite of squaring something is taking the square root of that number. So we can use our calculator to help us figure out, okay, what is the square root of 169? And when we take the square root of 169 on your calculator, what you are going to want to do is you're going to want to hit the second button. And then right above the x squared, so you're going to want to click the x squared button. So hit second and then x squared. And you'll see right above the x squared button, like written on the actual calculator, is a little teeny tiny square root symbol. And so when you initiate the second button, it's going to actually bring up that square root symbol for you. So you hit second x squared. You can type 169. So your calculator will look like this. And then once you hit enter, it's going to tell you that the answer is 13. So the square root of 169 gives me 13 equals x. And what that means is if we were to take 13 and multiply it by itself, 13 times 13 is 169. So let's go ahead and we're going to actually jump down to question number 3. And for question number 3 right here, I'm going to start by identifying my hypotenuse, or my C value. And that is always opposite of your right angle. So I can see that opposite my right angle, I have x, so I'm going to write a C next to it. And then I know that my other two numbers are my legs, so I'm going to label this as A and this one as B. And then from there, we're going to substitute into our Pythagorean theorem. So instead of a squared, my a value is 29. So 29 squared plus, instead of b squared, we're going to go ahead and substitute 14 squared equals. And then instead of c squared, our c value is x. So we're going to go ahead and substitute x squared. And then from there, you guys are going to want to use your calculator. So using your calculator, you are going to type in 29 squared. And on your calculator, you can just type 29 and then hit that little x squared button and then hit enter. Or you could type in 29 times 29. That would always be an option as well, depending on your calculator type. And when I type in 29 times 29, I'm getting 841 plus, for 14 times 4, or for 14 squared, I'm going to type in 14 times 14. And I am getting 196. And then I'm going to add those together. And I'm running out of room, so I'll just bring my work over here. I am getting 1,037 is equal to that x squared. So now what we are looking for is we are trying to figure out what number times itself will give us 1,037. And again, I wouldn't recommend guessing and checking. The opposite of squaring is square rooting. So we're going to go ahead and we're going to take the square root of both sides. On your calculator, you should hit second And then hitting the x squared button now should bring up your square root symbol in your calculator. Go ahead and type in 1037 and hit enter. Time when you take that square root, you should be getting a decimal, right? And it said to round to the nearest tenth. So I am getting 32.202, but I do need to round to the tenths place. So I can see my 2 is in the tenths place. That 0 is going to make that 2 stay the same. So 32 and 2/10 is equal to our x value. Now, what I would like you guys to do is go ahead and give number 2 and number 4 a shot, and I will have a separate video link for you to click on where you can then check your work. But I want you to do 2 and 4 on your own before watching the remainder of the video.